Okay, so these are our 612 notes. So in our note packet, we are looking at page 3. I do know that I already have these kind of updated online for you too, but it's good to talk about it at the same time so that we get some more practice. And actually, the one that we went over on the homework was a perfect question because that kind of brings us right into this very first set of triangles and where we're asking to find, are they congruent? Do we have enough information to determine that? So even though it doesn't have the 9 and the 13 listed on it like it did on the homework, this is the same set of triangles. We have our ABC and our DEF, and we already were able to tell that based on this information, it says if they have the relationship shown at the right, do they have to be congruent? Well, we already showed, there we go, that this AC, oops, let me get a marker here. This side AC and this side DF had a one-to-one relationship because we can see these marks here mean they're equal. So it doesn't really matter what number they are. In our homework, it was a 9 and a 9. We could say it's a 5 and a 5 or a 3 and a 3. The marks just simply mean that they are equal. So we know that those have a one-to-one ratio already. We also can see that AB and DE have the same markings, that little double set of marks on them. So they also have a one-to-one ratio. In the homework, it was a 13 and a 13. It could be a 10 and a 10. It could be a 4 and a 4. It doesn't really matter because it just means that they are equal. They have a one-to-one ratio. And we can also see that our angle A and our angle D have the same value as well. So again, in the homework, those were a 65-degree angle. Here, it doesn't really matter. As long as they're equal, that's what we needed to show side angle side. So we knew that they were similar, and we were able to prove, and we can see because of the markings, that they have a one-to-one ratio. So yes, they are going to be congruent. And again, same reasons as we had on the homework there. I'm gonna move myself over here and I'll just type it out because my handwriting is horrible. There. So I just typed it in. They are similar triangles with a one-to-one ratio between the sides. Okay? The sides are the ones that need the one-to-one ratio, not the angles. Angles have to be equal. I got a question over here. Okay. So it says then, write a conjecture in the form of a conditional statement or arrow diagram. I kind of have it set up for us as a conditional statement already, meaning a statement with an if and a then, based on this relationship. Remember, a conditional statement looks something like, if two triangles, blah, 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 then the triangles are congruent. So I already have it kind of filled out for us that we're just going to fill in a couple of pieces of information from what we see in our diagram. So it says if the triangles have blank pairs of equal corresponding blank and the blank between the two blank is equal, then the two triangles are congruent. So what on earth are we talking about here? So we're talking about pairs here. So we can see in this picture they have two pairs of equal corresponding sides. Okay, so AC and FD, I'll even put them in. So AC and FD were equal. That's one pair. And then we had our AB and our DE were equal. So that's our two pairs of equal corresponding sides. So we have that, and the angle between the two sides is equal, then the two triangles are congruent. And we can see that that angle in our picture was our angle A equal to our angle D. So if we have all of that information, we have two pairs of sides that are equal to each other, and our angle in between them is equal to each other, then that is enough to say our triangles are congruent. We no longer have to say they're similar first and then check for a one-to-one ratio. If we can already see they're equal, Why do we have to go to similar before we can go right to congruent? So why take the extra 2 steps to get around to our answer? So then it's like, well, what's a good name for this shortcut? Well, kind of. We've got a side, let me see here, that matches. We've got an angle in between that matches, and we have another side that matches. So it looks just like our similarity, but now instead of saying that the triangles are similar, we're going to say the triangles are congruent. So what we'll do is we'll just kind of copy over. We'll say it's still side angle side, but now instead of the similar symbol, we're going to put the congruent symbol. So we just put an equal sign underneath, and then now we're talking about congruence versus similarity. So that's a nice shortcut because it allows us to quickly say they're congruent without having to go through all of the big steps. So we have a couple other shortcuts we're going to look at today too. So Derek wonders, what other types of information can help determine 2 triangles are congruent? So we have 6, we can see here there are 6 tests that we're going to run. Do they have the side, the similarity? Do they have the 1-to-1 ratio? If that's true, then we can kind of shortcut it. We're gonna add this to our blue sheets here in just a little bit. So we know that side-side-side similarity exists. We want to know, does side-side-side congruence exist? So what they're saying here is, notice no measurements are given in the diagrams. So we're considering the general case of each type of pairing. So if we want, we can throw numbers in so that we can check it. But they're saying it doesn't matter what numbers we use, it's going to work no matter what. Or it will work or it won't work no matter what. So looking at our first set of triangles, we're trying to check, does side-side-side congruence work just like the side angle side congruence worked? So do we have similar triangles with a 1-to-1 ratio existing? So here we can see all 3 sides. So A matches with A, B matches with B, C matches with C. So if those match, is that enough to say the triangles are similar? Yes. They would be similar by side-side-side. And then the question is, does a 1-to-1 ratio exist? At least one pair of corresponding sides is equal. Well, yeah, we can see. And actually, in this case, we have 3 pairs of corresponding sides that are equal. A matches with A, B matches with B, and C matches with C. So yes. So that means this works, and side-side-side congruence is a thing. And we'll add this to our blue sheet here in just a minute. So then the next one we have here is our angle, 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 or AAA congruence. Is that a thing? So first thing we need to know, are the triangles similar? Could we use side-side-side or side, angle, angle to prove the triangles are similar? Well, we could prove they're similar by angle, angle. At least 2 angles. Here's one with a triple mark. Here's one with a triple mark. Here's one with a double mark. Here's one with a double. So we do have at least 2 angles, and in fact, we have all 3. So yes, they're similar. But do they have a side that's given to us that's equal? So like in the first triangle, we knew that A matched with A, B matched with B, C matched with C. We had that information. In this second pair of triangles, we don't have any sides are equal. So no, this one does not work. We don't have a 1-to-1 ratio, so this would definitely be a no. Angle, angle, angle congruence is not a thing. Okay. So what about angle side angle congruence? Is that a thing? So could we prove with angle side angle that we have similarity in some way? So do we have side, side, side? Are all 3 sides marked with something? No. Do we have side angle side? Do we have 2 sides marked with an angle? No, we only have, and in this case we can see we only have 1 side marked. Do we have angle, angle? Is there an angle in one triangle and then a second pair of angles in the triangles equal? Yes, we do have angle, angle congruence or similarity. So we have two pairs of angles in both triangles that are similar. So then the next question is, do we have a 1-to-1 ratio? Do we have a pair of sides that's equal? So, and it says corresponding sides. That's the important part here. So when we look at this M, we can see we have an M and then another M. We do have the same letter. Is it in the same spot? That's the big question. So this M that we see is in between the two angles. And is that the case over here as well? Is the M that they give us in between the two angles? Yes. So because M equals M, we have a 1-to-1 ratio. So that means this is another shortcut that we could use for congruence. So meaning we don't have to then always say, you know, if we have a picture that looks like this, we don't have to every single time go, all right, well, I have similarity and I have a 1-to-1 ratio. I can say, oh, I have two angles and a side in between. They're done. I don't even have to go into all the detail. So it gives us a way to shortcut this. All right, so then on part D, do we have side-side angle similarity? I'm sorry, congruence. Side-side angle. So we do have two sides and an angle. So we want to know, do we have similarity at all first? Because again, those are the two requirements. They have to be similar with a 1-to-1 ratio. So do we have side-side-side similarity? Well, I have a Q. Oops, let me undo that one. Try that again. I have Q matching with Q, and I have R matching with R. So I have two sides, but I don't have the third side given to me. I don't know how big this side is, and I don't know if it matches the one over here. So nope, side, side, side is not how I'm going to prove they're similar. Do I have side angle side similarity? I do have two sides. Remember that our angle, come on, let's try that, there we go. Our angle is supposed to be in the middle. So this angle that they gave us that's congruent is supposed to be between the two sides, which means that it should actually be up over here in between Q and R, and it's not. So while it looks like it should work for side angle side, the angle's in the wrong place. So this is not going to be a similarity method. And then also angle angle, we only have one angle given to us. We don't know how big the other two angles are. So we can't do that either. So right off the bat, we can't even prove they're similar, let alone having a 1-to-1 ratio. Two sides is not enough. We'd need all three. Or the angle they give us has to be in the middle, and it's not. So this does not work. So we don't have to worry about it. You could cross it off the list. And remember with similarity, remember we had like our side-side angle. If you turn it around, it's angle side-side. And we were like, yeah, you can't use that. It spells a bad word. So this is another one of those where it's like, nope, doesn't work. What if instead of side-side angle, we said angle, angle, side? So can we prove that they're similar and that they have a 1-to-1 ratio? So based on our similarities, we have three ways to show they're similar. Side, 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 we don't have three sides. Side, angle, side, we only have one side. Angle, angle, hey, we do have an angle here and an angle there. And we have another set of angles. So we do have two angles. Yes, so they are similar. Do we have a 1-to-1 ratio? At least one pair of corresponding sides is equal. So this is the big important part with this one. This was where it gets a little tricky. We have a side that's marked congruent. It's after, in my case, it's after that red angle. When I come over here and look, is that the same side? So if I put, I don't know, like an A here and an A there, are they in matching positions? And they are. Okay. If that side they gave us that was congruent was after the green line or the green angle, then they wouldn't be in the same placement. So that gets tricky. Most of the time we don't, we're not trying to trick you guys. We will give you them in the right positions, in the corresponding parts so that you're not trying. there's enough going on here. We don't need to try and trick you on that, on top of that. So yeah, so this is one that works. Angle side is a congruence method, just like angle side angle is a congruence method, because we have two angles and a side that shows a 1-to-1 ratio. All right, the last one is a tricky one. It doesn't come up very often. It says hypotenuse leg congruence. So the big question here, and the big thing with this one, is this is a right triangle. Notice specifically, these are right angles where all of the other triangles were not. So with this, if it's a right triangle, we can do Pythagorean theorem. We could do a squared plus b squared equals c squared to find our missing sides. And if we know that, I'm just going to put a little hypothetical out here. This is one where putting some numbers actually helps. Let's see here. If this was, I don't know, a 5 and a 4 in a right triangle, do we know how to find the missing side? Yeah, we can do our Pythagorean theorem. So I could do a squared plus 4 squared equals 5 squared, or in this case, x squared plus 4 squared equals 5 squared, and I could come up with my answer. Well, if we were told that in the other triangle, the sides that they gave us already match, if I already know that this is a 4 and this is a 5, well, wouldn't it make sense that these two sides would have to be the same because they're both right triangles and they have the same side missing? Yeah, so we could then figure out that both of these sides have to match. I know I didn't draw that very accurately, but that's okay. So we could, because it's a right triangle, we could do Pythagorean theorem and we could figure out the missing side. The goal here is that we don't have to do Pythagorean theorem to make these work. So we will be able to prove they're similar. In fact, we could prove they're similar by side, 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 or by side, angle, side. We couldn't do angle, angle, because we wouldn't have two angles. However, shoot, if it's a right triangle, we could do sine, cosine, or tangent and do the inverse and find an angle measure. So I guess actually we could do any of these because right triangles are special. They give us information that other triangles don't. And if we know that the sides are equal, because they gave us two sides, then a 1-to-1 ratio must exist. So it does work. HL is a thing. It's a very special thing, but it doesn't come up very often because it only works for right triangles. Okay. So here again, I have a slide here. I'm going to leave up. If you have your blue sheets, I would grab them out so you can write these down. I'm going to write it down kind of with you guys as we're doing it. And then I'm going to post it online as well. I know I didn't post the one from yesterday because I was like, it was just yesterday. And I wanted to fill out a little more of this before we got too far ahead. So these are the 5 methods that we just talked about. So we know HL is a method, angle, angle, side is a method, angle, side, angle, ASA is a method, and side, side, side is a method. And then we already worked with SAS up here. So we have 5 methods total that are shortcuts for proving congruence as opposed to saying, are they similar and do they have a 1-to-1 ratio? You can always fall back on that, but it's kind of being extra, and who really wants to be extra? So these are our 5. I'm going to leave them up here. If you don't have your blue sheet or you're not planning to write it down, take a little brain break maybe here as some other people get these filled out. And then we'll reconvene here in just a second. So I'm going to fill mine out too, kind of read them as we're doing them, just to kind of reiterate these methods and how we use them. And then we're going to use them in a couple of flowcharts, like 6 flowcharts. So our first one was our side angle side congruence. Use this color. No, I'm gonna use these pens. I had to decide what I'm gonna write with before I actually start writing. Maybe you want to bubble around those or something. These are the shortcuts. These are the names we're going to need to know. And then I have like some words describing them underneath. So we have if 2 pairs of corresponding sides are equal and the angles between them are equal, then the triangles are congruent. So we have 2 triangles here. We can see they've got some sides that are marked. They've been rotated a little bit, so they're a little tricky. You got to kind of turn your head for the second one in order to make them make sense. But I'm putting the SAS in the picture so that you can see how they relate to one another. And actually, I'll even do this. I'm going to change the color on these. Let's make that blue. I wanted to make it stand out. Ooh. There we go. There we go. So we can see these similarities and how they all work. Oops. No, don't do that. Yeah, that's all right. So we have a side AB that matches with that side ED. We have our angle B that matches with our angle E, and our side BC that matches with our side EF. Okay, so side, angle, side. Our next one we have is our side, side, side. That was the next one in our chart that we were working through. So side, 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 SSS congruent symbol. And this one is probably the easiest one to identify. All 3 sides of correspond, all 3 pairs. Oops, dang it. Pairs. Whiteout. All 3 pairs of corresponding sides are equal. There. So all 3 pairs of corresponding sides are equal. Then that makes our triangles congruent. So we have side BC is corresponding with ZY. We have side AB is corresponding with side XY. And we have our side AC corresponding with side XZ. Side, side, side congruence. Okay. And I'm going to move myself out of the way here. There we go. So we have our other 3 that we were working with at the bottom. Our angle side angle congruence. Okay, so now we have two pairs of corresponding angles. Are equal, and the sides between them are also equal. Then that makes our triangles congruent. So in our picture here, we can see angle B and angle E. Those are our right angles, are congruent. We have our angle C and our angle F are also congruent or equal. And then the side between them, BC, matches with our EF or FE. And that gives us angle side angle. You can almost read it if you mark the picture with those the letters for their parts. You can almost read, like even if I was to put the S up here, we can read it straight across. It says ASA as I look at the picture. So it's a way to kind of just make sure that we're doing it right. I like putting the S's on the outside because they're sides, and sides go on the outside and angles go on the inside. But I'm just moving this so we can read that a little bit more clearly. Alrighty. So our next one is our angle side congruence. We have two pairs of corresponding angles again, but this time the corresponding sides not between them. We call them non-included sides. It's another word for it. So I'm going to write this: two pairs of corresponding angles are equal, and the corresponding sides not between them are also equal. So we can see our angle B matches our angle E, our A matches our angle D, and our side AC, not in between the two angles, matches with our side DF, not in between the two angles, following in the same order. That's the trick. It's the order that matters. And then lastly, our HL. And this one is the tricky one because it's only for a right triangle. So if the hypotenuse and one leg of a right triangle are equal to the hypotenuse and leg of another right triangle, then the triangles are congruent. So the big deal here is that they have to be right triangles. If they're not, then it doesn't work. And that's because then you can't do the Pythagorean theorem to show that they are, in fact, always going to be similar. So you need the right triangle to be able to say that they work. Okay. I'm just looking to see. Okay, I was trying to remember what I had in here. So I know that took me a little bit on that same slide, just kind of reading through. I was also writing mine in there too, so I will post that online. Obviously, I have the notes posted already, but I don't have the blue sheet posted yet. So I just wanted to make sure that everybody had the same amount of time as I did to fill it out so that, you know, you have it. And if you don't have it, it's not a bad thing to hear me saying it either. But so what we are going to do then, we're going to continue on. Just double checking. Oh yeah, we got lots of time. We are going to do some more flowcharts because that's good for us using these methods, these shortcuts that we were just talking about. So we're going to kind of mesh this together, this idea. So we've done some flowcharts a little bit already. So we're going to do a few more. Okay. So it says here, writing our flowcharts, this triangle, this pair of triangles should look awfully familiar because it's the same one we used yesterday. So we're on page 4 now of the notes packet. And it says, which triangle conjecture shows that these triangles are congruent? Side, 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 angle, 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 side, or HL. So looking at our picture, we want to know, what do we have? So we see here we have BC is 4.5, ED is 4.5. I have AB is 6, FD is 6. I have AC is 7.5 and FE is 7.5. So all of those pieces of information given to us are sides. So following that then, we should be using our side, side, side congruence shortcut. So what we're going to do, and this is, we're doing our flow chart just like before, but they're going to look a teeny bit different, and that's okay. We're going to ask a little more information. I know. I'm like, oh yeah, it's the same thing, but we're asking more. We're not only going to have you complete the bubbles, but beneath each oval, we're going to state how we know that information, because it's not always going to just be shown to us in the picture like it is here. In this case, these are pretty easy. So we know, like, a couple of ways we could write this. We know that our side 6 and our side 6, they match up. They're corresponding. So I could write 6 equals 6, or I could write the actual name of the side, which is more handy because I'm not always going to be given a number. Sometimes I'm going to be just given a marking. So I want to just know what side is the 6. So I'm going to say AB and DF or FD. I know those are equal, and I know that because it's in the picture. So I could write underneath, in the picture, which is a lot of words. Not really, but you know, kind of. So another way we could show that, or we could say that, is that, well, it was shown to us. It's in there. I can see it. So we could write shown because they showed us that information. Or another word that you're going to hear me write or say a lot is given. They gave it to us. We were told that information. Both words mean the same thing, but they're nice little short words that we don't have to write a huge explanation out for why we know it. It was just there. If you want to write, it was there, great, perfect. It's the same thing. So let's see here. Next one, let's do appears to be the hypotenuse, the 7.5 and the 7.5. I could write them doing my ratio, my similarities, or I could just say, well, I can tell they're equal. So I could just say AC is equal to FE. And again, same thing. It's there. So I could write, it's there. Or I could say given, or I could say shown. Doesn't really matter. That's my other one, purple. And then I have my BC and my DE, or ED. 4.5 and 4.5 match up. And again, that was shown to us in the picture as well. So now I know that the triangles are in fact congruent. So I'm going to write my congruent statement. Triangle, I don't know, we'll go ABC again, just like we did yesterday. We're going to put our congruent symbol in because they're congruent, not similar. Well, they are similar, but they're also congruent. And then we're going to put in our second triangle. So if I go ABC, starting at the top, working my way around, so from the 6 to the 4.5, we'll do the same thing on the second triangle. From the 6 around to the 4.5, that'll be our FDE. And then our method underneath, why do we know they're congruent? That's the shortcut that we said. That's going to be our side, side, side congruent shortcut. I'm just realizing, I'm like, oh yeah, that's right. I didn't actually Harley Hope no Owen Day. Okay. It's like, oh, I didn't do my attendance yet. Probably should do that. All right. And that's it. So there we go. So we don't have to then, after the flowchart's done, go back and say they're congruent because we already did it. It says here in Don's congruence flowchart, I don't know who Don is, but in Don's congruence flowchart, he wrote AB over FD equals 1, bringing in the idea of our similarity ratio. In Phil's flowchart, he just wrote AB equals FD. Do they say the same thing? Yeah. One of them's just saying they're equal. The other one's saying that if I divide them, they're going to make 1. Well, if I said, 5 equals 5, sure, they're equal. If I say 5 divided by 5 is 1, well, that still tells me that 5 and 5 have to match, because the only way you can divide two numbers to make 1 is if the two numbers are the same. So the question is, and I kind of already went through this with you, can we always use problems like Phil's? Can we always say AB equals FD instead of having to write the fraction? Yes. So it makes it easier. We don't have to deal with fractions anymore because we're not trying to prove that they have the same similarity. We're trying to prove that they're not just the same ratio, that they are actually an equal ratio. So we want them to show they're equal to each other. So we're just going to do a bunch of these. Can we show they're congruent? So what do we have? What do we know? What can we fill in? So we can see in our picture, we have a 6 in one triangle matching with a 6 in the other triangle. So I'm going to say PQ and ST. I can see those are equal. That was already there in the picture to begin with. So that was shown to me or given to me. I can also see that I have a 120-degree angle in one triangle, and I have a 120-degree angle in another triangle. So I'm going to add those markings in as I'm working through this so that it makes it easier for me to identify after the fact. So I can see angle P is equal to angle T. Again, that was already marked for me in the picture. That was shown to me. And so now I want to kind of analyze this photo and see, or this picture, this diagram, and see, is there anything else that's useful in here? Do we have any parallel lines? It appears that we do, but we don't have any arrows to suggest it. Do we have any shared sides like we had done yesterday? We had a bunch of triangles that were sharing a side. Don't have any of those. We do have them. They're kind of...
Would the point R be like a vertical angle?
It is, yes. Right here at point R, they're sharing this point, but we can see that across from point R, we have an angle and another angle. Those are going to match. So it wasn't given to us that they are equal, but we know that when vertical angles are kind of come together, when triangles come together and make vertical angles, that they're going to match. So we don't want to say just angle R because, again, there's a bunch of them. There's actually 8. There's actually 8 angles at point R there. I had to think, I'm like, how many do I have? There's 2 acute angles, there's 2 obtuse angles, and then there's actually 4 straight angles at point R. One on the left, one on the top right, one on the bottom right, and one on the bottom left. Like, there's a bunch of angles in this picture at point R. So we want to be more specific. We're going to use 3 letters to identify. What's up, Braxton? Oh, okay. Maybe he's like, oh, I accidentally bumped it. So we're going to use 3 letters to identify this angle R on the left and 3 letters to identify angle R on the right. So if I want to talk about angle R on the left, I'm going to say like PRQ. And if I want to talk about angle R on the right, I'm going to say like SRT. And I'm going to put my angle symbol so I know I'm talking about an angle. So we can tell those angles are equal. It wasn't given to us. They didn't show us that they were equal right off the bat, but we were able to identify that because of the information we know about angles. So it's not that we're going to write shown, we're going to write what we know about those angles. We know they are vertical. So we'll put that underneath. And now we can see we've got 2 angles and a side that we know are equal. We know our vertical angles. I'm going to put a little A for angle. I'm going to put 120. I'm going to put an A for those 2 angles. And I know that the side 6 matches as well. So I have a side and an angle, or I have an angle, side in my triangle. So I can see that I've got congruence. I've got one of my shortcuts. So I'm going to put that there, angle, side, congruence. And then I'll put my triangle statement in there. All right, so now I just have to figure out what triangle statement I want to put. So like triangle, anybody have a particular order they want to use? Nah. All right, how about QPR? Oh, come on, pen, you can do this. There we go, QPR. So I'm starting at QP, that's the red side of the triangle, and then wrapping it around those angles. So QPR. So I want to do the same thing on the second triangle. I need to go across the red side and then across the double angles that are congruent. So I'm going to go STR for the second one. There you go. So it's just identifying what we see, working with what we have, and trying to come up with anything else that might be true. So first thing I would always do in each of these triangles is go through and say, okay, what do I see? What do I already know has to be equal? So on our next triangle, we've got, let's see here, we see some arrows and I see some angles. So I can see in this, I've got an angle B matching with an angle D. So I'm going to go ahead and start with that because those are angles and we already can see they're equal. So that was shown to me or given to me. I'm going to write given just because that's just to show you that it's the same thing. And that's all I can see that's given. That's equal. I do have parallel lines. So I have something like this, parallel on top, parallel on the bottom, and I have this line that connects them. And I know that if I have parallel lines, that the angles around those parallel lines, here and here, those angles have to be equal. So in our picture, we're talking about this angle at the top and this angle at the bottom. Try to transfer that information back in. So I can't just say angle A because there's multiple points at angle A. So I could say angle BAC or CAB if you want to spell words. Sometimes it's fun to like, oh, what kind of words could I come up with? BAC is equal to, and then on the bottom, I could go DCA or ACD. As long as C is in the middle, that's telling me I'm talking about angle C. So how about DCA, just because. So those angles are equal, not because they were given to us, but because we know that if we have parallel lines, then we have equal angles. Anybody remember what those angles are called? Owen, any idea? He's like, No. Oh.
The angles we just did?
Yeah, those green ones.
Alternate interior, right?
Yes, those are alternate. So that's what we would put as our reason underneath, alternate interior. Bailey, were you going to have that one?
Yeah.
Sorry. All right, so then for the last thing, I've got one more bubble I need to fill out in order to show these are congruent. So is there anything else that I can see I know must be equal in these two triangles? So looking at them, thinking about this, already got these angles. I can't do the other two alternate interior angles, and actually that wouldn't help because angle, angle, angle isn't a method for congruence. But I do know that both triangles are using this line. So we have this triangle on the left and this triangle on the right. They both use that line in the middle. So they are both using AC. So I know that it's going to match itself. Or I can write AC is equal to AC. Or CA is equal to CA. Because both triangles use it. So it must give, that's where I'm getting my 1-to-1 ratio from. That part's equal. That's kind of from yesterday what we were talking about. Anybody remember or have an idea of what reason we would use for why we know this part matches? If they're both using it, little kids are both using the same toy, we say they're doing what? They're being so nice. Look at how cute and how good they both share. They're sharing. That's what our triangles are doing. They're being so friendly to each other that they're sharing that side. And they're like, oh, it's okay. You can use it too. So they're sharing and they're being really good friends. And so that's why we're able to say that part is also equal because it's both being used by both triangles. So that's a side that's given to us or that we can tell is equal when they're both being used. So now here comes the fun, tricky part is putting in our triangles. The first one doesn't really matter. We could say, we could go ABC even if we want to just stay with our alphabetical. Come on, pen. ABC is congruent to, now here's the trick. If I go ABC on the first triangle, I've got to go in the same corresponding order. So A was my triangle, and here's where color also helps a lot with these triangles. A is my green angle, and then I'm going to my blue angle and then across this outside part of the picture. So when I come to the second triangle, I need to start at the same green angle. So on the bottom is the green angle, and then you need to go to the blue angle, which is actually going outward, so and then back up and around. So I'm going to go CDA. And then our method for congruence is, well, we got to figure out, well, I have two angles and I have a side. The question is, where's the side? So here's my angle, here's another angle, and my side is not in between the angles. It comes afterwards. So this is, again, an angle, angle, side congruence. Okay. Couple more. The more we do them, the easier they get. I don't even think you have a bunch of, I'm trying to think. On the homework, I was just looking. Oh, we don't even have you doing this on the homework yet. It's like, let's practice them together first. So Monday night, you'll have it on homework, but you don't have it on homework for tonight. Yay. But it's just trying to get you guys some practice somewhere since it's not on the homework. All right, in our next one, we're trying to determine, are they congruent, similar, but not congruent, or not similar, and kind of working through. So let's look at what information we already know. We can see here in our picture, we know that angle G and angle I are equal to each other. And that was shown to us or given. When we look at our sides, though, we have 5 and we have 4. They're not equal. So that means these triangles are not congruent. 5 does not equal 4, so these are not congruent triangles. So I could add that into the picture or into the flow chart if I want. I could say, you know, FG does not equal IJ or JI. And again, that's shown to us or given to us, however you want to write that. We do have one more pair of angles that are equal though. We can say in the middle, we've got those vertical angles again. So we could say angle FHG, because I want to follow this around, FHG on the left is going to equal angle, and we could go JHI on the right. And that's because they're vertical, so we know they must be equal. So we do have two angles that match, but we do not have angle side angle or angle angle side like we had before. So we do not have congruent triangles, but we do have similar. So these are similar, but no, only one T in that kind of but not congruent. There we go. So we're going to go ahead and mark similar, use our similar symbol, but not our congruent symbol. So we can say FGH. I'm trying to, nope, that's FH. FG doesn't really matter. FGH, as long as whatever your second triangle is follows the same order. So if I go FGH on the left, I'm going across the side that had a number and then towards my two angles. So I'm going to do the same thing on the right, JIH. And they're similar because they have two angles that are equal. So they're throwing on a little bit of review in there. On our next one, we have two triangles. They kind of overlap a little bit. I'm going to even kind of draw them separately and relabel them. So I have this S-U-T, boom, boom, boom. And then I have the other one, looks kind of like this. I've got T, my battery's dying on my pen. Come on. Come on, we can do this. Done it before. Ah! What did I just do? Come on. Everything's going crazy. Okay, let's try this. Nope. My whole smartboard is just, file is like, I wasn't moving it. Undo. What the heck? Look at, that's so weird. What is going on? The whole thing just like went crazy. Trying to hit undo, it's not letting me undo. I don't want to do that. Cool, it just froze on me. That's fun. It's like, okay. This is a new one. I'm used to other technology issues. I'm not used to this. Heck. Let's see here. If I do this and just use the touch screen, will that work? Nope. Oh, oh. It almost, wait, no, forward, no, backwards. Okay. I think I got it. Try this again. Okay. It just sort of, it had a moment. It just needed a moment. It was like, you know what? You've been writing for a while. How about we just pause for a second and make you really worried here. There we go. Okay, so I just drew them as two separate shapes so that I could see them a little bit more easily. So I can see that they do both share that TU through the middle. So they're being so friendly with each other. They're sharing that 3. Both triangles are using it. They're like, oh, we're friends. But when we're looking at these pictures, so again, congruence means that they have exactly the same size, same numbers. So we can see clearly these triangles are not congruent. The one triangle only has a 2 and a 3, and the second triangle has a 3 and a 6. They're different sizes. So they're clearly not congruent. Again, but maybe they're similar. So let's check for similarity. So let's do smallest side to smallest side. So in our triangle, we have the smallest side on the first one is 2, and in our second triangle, the smallest side is a 3. So if you want, you could write SU. I think I did this. SU over TU gives me 2 over 3. You don't have to put the SU over TU, though. It's just nice to kind of, okay, where are those numbers coming from? We can see that angle U matches with angle T. Oops, and these were shown to us. These were given. And then we can see we got our biggest side here. We have our 3 matches with our 6. So TU and TV, 3 matches with 6. Now, here's the thing. If I reduce 3 over 6, do I get 2/3? Nope. 3 over 6 is 1/2. That was also given or shown to us. So is that enough to say our triangles are similar if one ratio is 2/3 and the other ratio is 1/2? No. So these are not similar or congruent. So we could just write, actually, let me make this even easier. We could just write not similar. I think on my key online, I wrote triangle SUT and then put a slash through the similar symbol and then triangle UTV. So, and that's because this fails our side angle side. You don't have to go that far, but that way you have a nice explanation. Okay. One more here, last one. We've got these 2 triangles here. We have PQR. We have a 12 and a 13 on it. We have a KML. We have a 13 and a 5. So we can see that we have one side that's already equal. We also see that these are right triangles. So this is actually some nice important information for us. So there's several things we could do to show that what we know about these triangles. Lots of things. And it depends on what your method is to decide, or what your strategy is to figure out what method you're going to use. So are you using side, 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 angle, side, HL? Like, you could use any method pretty much in these triangles because of the numbers that we've been given. The thing is, you got to find some information first, because right now only 2 parts really match. The angle P and L match, and the 13 and the 13 match. 2 parts is not enough. We need 3. So, biggest question here is, what do we want to find? We could find side PQ pretty easily by doing our Pythagorean theorem. We could do a squared plus 12 squared equals 13 squared and find our missing side. 12 squared is 144. 13 squared is 169. We subtract. Some of you have done this before. May remember what our solution is going to be already. 169 minus 144 is 25. So we'll square root both sides, which means our missing side is 5. There it is. That's important information. Because now we can see that we have a 5, 12, 13 triangle. The other triangle has a 5 and a 13 as well. We're missing a side. What do you think that missing side will be? Probably a 12. You could prove it by doing your Pythagorean theorem again and working through it. You don't have to, but it's good practice just to say, well, here's how I know. In this case, we could tell pretty quickly that the missing side is going to match our other triangle. 169 minus 25 is 144, and the square root of 144 is 12. So we can prove that this missing side is 12. And now we can see that we have triangles that have exactly the same sides all the way around. So in our case, I could say, well, PQ matches with ML. It was kind like one of the parts was given to us, but we also used the Pythagorean theorem. So you could say given, you could say Pythagorean theorem, you could say both. Doesn't really matter because we were able to, using the given information is how we came up with our missing side too. So I'm going to go ahead and just say given, even though we did have to do a little bit of work with that given information. We also know that PR and KL match. They're both 12. PR matches with KL. Using the given information, we were able to figure that out. And then there's actually, now we could either say angle P equals angle L, or we could say QR equals KM. Doesn't really matter which one, which strategy, but your answer has to, your method has to match your bubbles. So if I say QR equals KM, that was also given to us, then that means the method that I'm using was from the three sides. So my method down here is going to be my side, side, side congruence. If I had said instead for the third oval, angle P equals angle L, then my method down here from the bottom would be side, angle, side, because I'm using a different strategy to get to my solution. So it just depends which method you're using. What your bubbles say describes your strategy down here below. So if I go with PQR for my triangle, 5 to the 13, then I need to do the same thing on the second triangle, so I'll do LMK. And there's my triangle.